Historically, website architecture served a single audience. We built for a human reader, prioritizing visual appeal, clear navigation, and the eventual click. Today, that single reader ecosystem has been superseded. A second, invisible consumer is crawling the web, demanding a different architectural standard. The first reader remains the human user. They carry context and initiate clicks, and overlook structural code errors as long as the page renders quickly and looks cohesive. This data flow represents a standard search query, splitting into two distinct high-speed streams based on the nature of the requester. The second stream is the large language model. It generates 0 clicks. Instead, it reads an entire site at once to extract facts and cite sources in a generated response, bypassing your interface entirely. A human will stay on a page if the interface is appealing, regardless of messy underlying structure. An AI model encountering that same compromised structure will silently abandon the page for a competitor. Large Language Model Optimization, or LLMO, defines the architectural discipline required to satisfy human eyes and machine algorithms through a single structural standard. This network graph illustrates the modern dual pathway. On the left, a human inputs a query, clicks a link, and loads a visual document object model. On the right, an LLM processes the query, reads the raw text, and outputs an answer with a footnote, bypassing the click. The AI pathway ignores the user interface. It dives straight into the foundation, scraping the raw architectural underpinnings of the site. Modern web survival requires engineering a single, unified environment that renders perfectly for the human while presenting a flawless data structure to extraction algorithms. Visibility begins at the bedrock of web architecture, server-level crawler access. Technically sophisticated, beautifully designed sites often fail to appear as AI citations. The failure usually occurs long before the content is even read. This map compares two tools that isolate where AI is blocked. On the left, the mobile-friendly test hits a barrier. On the right, PageSpeed Insights renders the page. The mobile-friendly test is a binary gatekeeper, measuring if Googlebot can reach the server. This test respects the robots.txt file. If the server blocks the bot, the gate is locked for all AI models. PageSpeed Insights simulates a human user. It often ignores bot-specific roadblocks, successfully loading the interface and creating a false positive for site health. When results from these two tests diverge, you have a structural gap. If the server blocks the bot, the AI model is rendered completely blind, rendering your high-level marketing strategies utterly useless. Moving upward from server access, we address the structural makeup of the loaded page. This phase requires clean site architecture, optimized load speeds, and strict HTML semantics. This architectural stack begins with a base layer of open server access and a clean robots.txt file. The middle layer secures core web vitals and HTML semantics directly on top of that server bedrock. AI models operate on strict compute budgets. They prioritize indexing and citing pages with efficient load speeds and clean parsing structures over those that waste processing power. These classic technical SEO techniques now serve a new purpose. Beyond ranking on a search page, they provide the essential scaffolding for AI entity extraction. This core web foundation is non-negotiable. Without load speed and semantics, advanced AI strategies collapse before the model even reads the first sentence. At the apex of the stack sits the written content and the specific methodology a large language model uses to ingest it. When formulating an answer, a model selects only one or two sources. It prioritizes structural clarity and factual density over keyword frequency or traditional prose. Watch an AI scanner read standard corporate text. Subjective adjectives like industry leading are discarded. Only distinct objective data points remain highlighted. These highlighted facts lift off the paragraph and reorganize into a clean, hierarchical data structure, independent of original marketing copy. This defines the primary directive. Content must be purposefully structured to isolate factual claims into clear, named entities. On-page content requires a strict architectural separation between objective, extractable claims and subjective marketing language. This visual illustrates precise structural cleavage. A complex body of text must be broken into clean, usable components that a machine can parse without ambiguity. The goal is semantic citability. This is achieved through rigorous formatting, not algorithmic manipulation or prompt engineering tricks. Facts must be written as standalone sentences. If a claim loses its meaning when removed from its paragraph, a model will not cite it. Text is a data entity. If an LLM cannot cleanly separate a fact from marketing fluff, it will ignore the page and cite a competitor with better data structure. This structural logic extends beyond the website architecture itself. Third-party platforms like YouTube and LinkedIn operate on these same principles of entity citability. This expanded network graph shows identical data entities being extracted simultaneously from a website, a LinkedIn post, and a YouTube video. Zooming in on YouTube reveals the model is reading, not watching. Pulling back the interface exposes the underlying transcript acting as the source. Video transcripts function as raw, indexable text files. Models read them holistically to gather context and verify facts. Consequently, video titles, descriptions, and spoken transcripts must be meticulously formatted as clean, readable sources for model extraction. A unified, structurally optimized strategy across all channels ensures the AI reinforces the exact same entities for your brand, regardless of the platform. Surviving a web split between two readers requires abandoning one-off optimization tactics in favor of a multi-staged, cyclical pipeline. The total design process moves through 4 stages: technical audit, SEO foundation, LLMO layer, and iteration. The first 2 secure the bedrock for bots and humans. In the third stage, the LLMO layer refactors content into highly citable, entity-rich structures. The final stage of iteration involves a shift in how we measure analytics. Traditional click-based metrics can no longer capture your total visibility. This dashboard illustrates the new standard for tracking success. The left column tracks traditional search clicks, while the right column strictly monitors AI citations. AI visibility is an engineered system. Architects who continue to build exclusively for the click will soon find their content invisible to the machine.